Hello, everyone, and welcome to today's webcast, What Observability Means for Python Developers, sponsored by Lightstep. I'm Tracy Cook with ADT Magazine, and I'd like to welcome everyone. Before we begin, though, I'd like to take care of a few housekeeping details. We'll take questions today after the presentation. Please submit your questions anytime during the webcast, and we'll answer as many questions as we can. This webcast is being recorded and will be archived for future viewing, and we'll send you an email when the replay is available, and that should be in about 24 to 48 hours. And now I'd like to introduce our speaker today, Katy Farmer, Developer Relations Manager at Lightstep. Katy loves to experiment with code, break stuff, and try to fix it. Over the years, she's been an editor, juice bar barista, IT technician, and manual laborer. So she's learned a lot about failing and trying again, and in a lot of different industries. Ask her about Ruby, Go, video game development, Russian literature, Star Wars, Dragon Age, or chord progressions, and she'll be your friend right away. So you're in for a very interesting presentation. So without further ado, I'd like to pass the event over to Katy. Katy, please take it away.
Thanks so much, and welcome everyone. Thank you for joining us today. There's a lot of things you could be doing with your time, and you're here, so thank you so much. So first of all, hi, I'm Katy. I'm a developer advocate at Lightstep. Basically what that means is it's my job to help people understand the technology at the company and make sure that user feedback and input of any kind is heard in the company. So you can think of me as your technical friend, an engineer who lives in marketing. My Twitter handle is here. Feel free to reach out. I like to talk to people. That's why I'm here today. So we're going to go over a few things today. One sort of piece is what is observability, and then we'll talk about what it means in your Python applications. So to get started, step one, what is observability? Now, if you've tuned in, maybe you already know what observability is, in which case, congratulations, you're ahead of pretty much everyone, and me too. So when we talk about observability, what we want is to understand our systems a little better. And the origin of this actually comes from something called control theory. And this is a really scientific definition. Basically, control theory is this idea of how well internal states of a system can be inferred from knowledge of external outputs. Now, if this sounds like it means nothing to you, like it's totally fine. It's good to know sort of like the fundamentals, right? Like, where does observability come from? Here's its origin, right? Think of like chemical engineers who need to understand like the state of a chemical reaction. That's not something you can just find out or look at. You have to have some way of knowing from the outside. But really, that's not easy to understand. And it's not all that relevant to your work in Python. So let's try again. What does it really mean to have observability? Observability can be viewed as our ability to answer this question. What is happening in my system? Like, what's going on in my application? What's going on with this service over here? What's going on with this deployment I just pushed? These are questions that you probably hear all the time. And these are questions that I kind of like yell at my computer a lot too, just like, what's going on with my code? These are the questions we're trying to answer because we work in a system where we don't immediately have access to answers. But what if we did? observability is our ability to navigate from effect to cause. Now, this is important because you'll notice I didn't say this is cause and effect, right? When we deploy code, we see the effects. We see a spike in errors, maybe. And then we have to trace it all the way back and find out, it was caused by a misconfiguration. Or maybe you see increased latency. You say, this is slow. I wonder what's going on here. These are the kinds of things that mean we need observability. So maybe we can trace that kind of increased latency back to new customer behavior. Or maybe just complaints, right? Maybe your support team is fielding more requests, and then you figure out, it was because of this upstream service that was deployed. Our ability to react to these effects and then navigate back to the cause is observability. It means that we can ask questions of our system like, what is going on? And be able to answer them. Now, this has kind of always been a problem, right? Like, we always needed to be able to ask these questions. Every time we push code or create new features, this has sort of been the same. So how did we get here? How did we get to the point where we need observability? What changed? Well, something interesting changed for developers. So this is sort of what it used to look like. Maybe you had a monolith. You had a database. You had your Python application. And then you had, your users, your client. This was a pretty straightforward way to interact. In a lot of ways, when you asked questions, you could answer them from your system because your system was relatively simple. But then we started to scale. We started deploying microservices and breaking our monoliths down. This means all these moving pieces suddenly start being harder and harder to track. So what changed for developers is that now there's more pieces than ever. There's more possibilities for where the answer to your question could live. So it's not just database application user. Now maybe it's multiple databases, multiple services, third-party integrations, different types of users. So the real answer for what changed is scale. Because when we had our monoliths, our more traditional architecture, we thought of it as a different kind of scaling. We thought of it as what we call scaling wide. You can think about scaling wide like a puddle. When we add water to a puddle, fundamentally what we have is just a bigger body of water. A puddle can become a pond. Pond could become a lake. A lake might even become an ocean. But fundamentally what we have is a body of water. The thing that it is stays the same. Just simply the size of it is different. This is what we think of as scaling wide. So when you had a monolith, you might add users, add hardware, that sort of thing. But fundamentally, you have the same service. But we are talking about a different kind of scale now. This is what we call scaling deep. Now, the better metaphor for this is to think about a village. A village, when it grows, you add more houses and more people and more roads, eventually becomes a city. And when you think of a city versus a village, they're not the same thing. They are degrees of complexity apart. You can't navigate them the same way. In a village, you might be able to just ask someone, where does my friend Anna live? and they can point you to her. But in a city, there might be multiple steps. You might have to say, okay, well, Anna lives in this part of the city. Does someone know how to get me to this part of the city? Then when you navigate to this particular neighborhood, then you might say, okay, I know Anna lives near a donuts shop. Then you might ask for directions to a donut shop. And you can see fundamentally the way we navigate these two is different. This is what we call scaling deep. When the degree of complexity changes so much that what you have is fundamentally different than when you started. So for us, what that means as engineers is the amount of things we can control has stayed the same. A lot of the times we write more or less the same code. We're in charge of new features or performance or QA even. But the things we're responsible for has been growing. So think about, sort of the last piece of code you wrote. And then think about all the things it had to be compatible with across your organization or your teams, or even maybe some of your partners. Suddenly the code we write, although it fundamentally stays the same, has to get along with and be understood by a much bigger organization. So the things we're responsible for are increasing, but the little pieces we control are so small. And this is why we need to be able to ask questions about our system. And I understand that this waxes a little philosophical, right? I understand that what we're talking about are these deep systems. They're complex, they're different. So let's take it back a step. What does it sound like? How do you know if you have a deep system? Well, here's a couple ways you can tell. Deep systems might sound like someone saying, where's Chris? I'm dealing with a P0 and no one knows how to debug this. You might be familiar with this idea that there's only one person on your team who knows a specific part of the code base, who knows a specific feature well enough to deal with emergencies. It could also sound like, well, I didn't know that database was a dependency. Well, I didn't know we needed Mongo to do that. Not knowing about parts of the system is a sign that you have a deep system, because of course you don't know it all. It's complex and varied, and a lot of it is outside of your expertise and your day-to-day. It can't be our fault. Our dashboard says we're healthy. If you have dashboards that you rely on for health, cool, but they can often be misleading if they're not representative of sort of the broader landscape. Your piece of the puzzle might be working fine, but that doesn't mean that it is not adversely affecting other parts of the code base or of the product. That was on a dashboard, but I can't find it anymore. This is a problem I've had many times, which is that if you have trouble even finding, the dashboard where this particular metric lives, I mean, that's a sign that you have a deep system, because, well, the harder it is to find means the further removed from you it is. And the more pieces of this architecture, this engineering sort of organization that are removed from you is a sign of a deep system. And basically what we're getting at here is that knowing what's going on in deep systems is a little bit tougher and requires some different thinking than we used to do. We used to be able to observe our applications with pretty much just a traditional sort of APM, right? But now we need things that can cross service boundaries. that can understand where things are failing, sort of with a broader reach. So how do we sort of achieve this? So you may have heard the phrase, the 3 pillars of observability. We're going to kind of like change this up. The 3 pillars of observability, yes, are very important, but we kind of think of them as telemetry. These are metrics, logs, and traces. They are very important to understanding your system and being able to answer questions, but they're not the only things you need in order to have an observable system. Basically, you can think of them as data sources. These are 3 types of data you can be collecting in your system at any time to be able to measure and understand what's going on. But they each have their own limitations, which is why you often see people saying you need all 3. And if you have more questions about sort of, how or why we're being a little picky about saying the 3 pillars of telemetry aren't everything, I highly recommend this talk by one of our co-founders at Lightstep. He does a pretty good job explaining why we think, yes, of course, they're very useful, but they are not the beginning and end of observability. And a lot of this comes down to the fact that like traditional tools that we use weren't built for deep systems. I mean, I have sifted through a lot of logs in my time as an engineer, and I'm sure that you have too. It's where a lot of us start when we see problems. We say like, something went wrong. Let me just check the logs. But checking the logs, although it's often my first instinct, is really time consuming. And not to mention that the logs themselves often come with cost. I wasn't that accustomed to using dashboards, honestly, until the last couple years. And I was always sort of thinking about this, like, is this easier than sifting through the logs? And that sort of depends on the dashboard, right? But that being said, it's still very hard to find a root cause by looking at a dashboard. You might see interesting patterns. There's definitely a lot of like valuable data in them, but dashboards don't always do a good job showing the complexity of deep systems. They might show you one piece or your piece, but not necessarily how those things overlap. And this means a few things, both for you and your company, right? Which is more time spent on call. When you can't see what's happening in your system, and you're going to get more pages in the middle of the night or in the middle of the day or on the weekends. Whatever time is the most inconvenient is when I find that they happen, which decreases your development velocity, whether that's because you spend your time with these on-call emergencies or you're constantly trying to make up for some of those failures. It's very hard to stay focused on moving forward when you have fires to put out constantly. It also, I think the current approach sort of forces you to rely on what we call tribal knowledge, which I don't think is a great term for it for a lot of reasons. But this idea that like, oh, only Anna knows how to fix this. And if Anna is gone, if Anna's on vacation, then we can't fix this. And that's a problem. And then I think maybe the biggest problem of all for this kind of approach, for all the time you spend digging through logs and putting out fires and trying to figure out what went wrong, is that you end up really tired. Your engineers just are exhausted. They don't get to work on fun new things. They have to be ready to be on call all the time. it's not a great way to work. So this kind of reduces productivity and happiness overall. Okay, so now, we're here for the juicy bits. It's the Python. So what does it mean? We're talking about all this observability. So what does it mean in, how do you actually get started with observability in a Python application? First of all, I'm going to recommend an open source tool. Hooray! I'm going to recommend OpenTelemetry. It's in alpha right now, but it has really excellent resources and a really strong team working on it. Lots of folks from Lightstep and Google and many other companies all sort of working towards this standard. OpenTelemetry is Sorry, I took a deep breath and then I just held it for a moment. It was very relaxing. You should try it too. OpenTelemetry is an open source library for standardizing tracing, which is a lot of words. But basically what it does is it helps you add tracing to your applications in a way that is sustainable over time and takes the least amount of work. So I put some code up here so we can see what does it really look like to start adding telemetry to your Python application. And it's pretty straightforward. You import the libraries from OpenTelemetry, and then you sort of initiate a trace. The idea here is that we can follow this trace anywhere through our application because we have a few different ways to identify it. You can see in this example, I have my spans, which are parts of the trace. My spans are called Fluffy Bunny Baby, which is just fun to say. That's why I used it. But this way, because I can name them, I can give them IDs, I can give them context that stays with them as they travel throughout our application. We can start really keeping track of where they're going. So, sorry, let me back up 1 second. So this is sort of a little getting started script. When we run this Fluffy Bunny Baby, we should get a result that looks something like this, which is that if we ran that little program, we'll see the text that we wanted to print to the console, and then we'll start to see the trace being printed out too. And then it will show you each one and its parent. So this is a really fast way to start adding telemetry to your application, right? With just a few extra lines, I've sort of added this ability to keep track of information, or I think probably a better way to put it is I can keep track of a request for its entire life cycle across the system. So this is obviously a very simple example. I think it's good for getting started. Obviously, your Python applications are going to be a lot more complicated, or maybe they're not. You can dream, right? But what they will have is a lot more third-party integrations. And that's the sort of thing that you really want to keep track of. So as you create traces and spans, you can trace a request as it goes from the database to your Python microservice to maybe a secondary API to make another request, follow that lifecycle, return back to the microservice, and then move on to the client. There are a lot of paths that a request can take in your system. It's a complex, deep system. this gives us an easy way to identify the traces and follow them the whole way through. OpenTelemetry in particular has a lot of resources for Python. I've added links here because I think it's really important when you're working, I mean, in most languages, but Python in particular has so many good and valuable third-party services, right? Lots of interesting libraries, and especially if you're doing anything with like data science or machine learning, you're going to want to be able to trace across many, many different types of requests. And so I wanted to add links here that I felt would be really helpful for you. So there's an OpenTelemetry Python client. All of this is in alpha. I just want to like emphasize that. All of this is in alpha, but you can absolutely start it and try it. I have, maybe, you know, it's an alpha. Don't put it in production. But it has a really active community of people who are well, really good at this stuff. So there's an OpenTelemetry Python client. There's also an OpenTelemetry Flask client. There's a guide to getting like a Python quick start. So you would use OpenTelemetry to add traces and then send them to Lightstep so you can see what those traces look like. And I'll show you an example of that in a minute. But maybe the most important one here is the OpenTelemetry HTTP requests. There's a link there for like getting started. This is a really good way in your Python applications to send traces in these requests with the request library, because we know that like most people are using it. So we want to make sure that it's part of the standard. So this is like not that many steps towards immediately getting information from your Python application. And there's some good news and bad news, right? The good news is, like, hooray, you already know how to get started. The bad news, a little bit, is that your application is getting deeper. Your stack is changing. And not this stack, although this is arguably the best kind of stack. Instead, we're talking about whether you're a Python shop or Java. There is just this issue of how the software you and your team write fit together with software developed by the rest of your organization, or even by other people outside. So how does it work with between engineering teams? How does it work with partner organizations? How does it work with open source contributors who want to add to it, right? Now, if your org has already started migrating to microservices, then you probably are already very familiar with what I'm talking about, right? I mean, it can feel a bit like you and your team and your services are kind of a cog in a machine, but well, you kind of are, but in a good way. You probably have a diagram like the one I'm showing you that tells you how your services fit within that machine. I mean, maybe you're already building on Kubernetes or functions, but here's the thing. I mean, nobody really deploys or builds software in isolation anymore. So even if you're not running on the latest version of Kubernetes or developing using serverless technology, chances are you still have a deep system. There is still software in your organization that you didn't write and don't control, but that you depend on. And that's true whether or not you're building in the cloud or using open source software as part of your production system, or using these third-party APIs to build part of your application, right? Again, nobody builds software in isolation anymore. On all of these things, they lead to distinct layers of ownership. And you might own the service at the top or in the middle, which arguably can be more difficult. But in any case, you've created these interdependent components, and you need something to help you understand that interdependence. And that's observability. So think about all of the dependencies of your current Python application. It could be a machine learning library. It could be a maths library. Whatever it is now adding to these layers of complexity and this interdependency. Being able to diagram out those dependencies is basically observability. So now we're at the sort of observability in action, which is where we get back to talking about like that I linked in a previous slide to this sort of getting started with Python and Lightstep. If you follow that guide, you're going to be able to sort of hop ahead to these steps really quickly. So when we say we are an observability platform as a company, most folks don't know what that means. Frankly, I didn't know what it meant either. But really, it means that we help you answer questions about your system. And this includes a few things, right? So we want to easily be able to see and understand our highly distributed environments. We don't want to have to spend like ages trying to map out our complex, deep systems. We also want to be able to like immediately pinpoint performance regression. This cuts down on that sort of that on-call exhaustion, I think I'll call it. You want to immediately figure out where things are starting to come apart. You also want to enable your developers to ship with confidence, right? Like, how many of us have shipped code and, you know, sort of just crossed our fingers and hoped for the best? Like, I wish I could say that I hadn't, but sometimes it just feels inevitable. You want your developers to be able to ship code and know that if there's something wrong or something, you know, less than ideal, then you'll know about it as quickly as possible. And you also want to be able to enable like easy sharing of information. Because your system is complex, you want to be able to share information with people across teams and services, and to be able to keep context. And this is the same way that we talked about with the sort of Python traces, right? You can add these like all this identifying information that helps you know what's going on in a particular trace. This is the same way that we want to keep context in our own minds as we look at a solution, right? Like if I have to still figure out, well, what service am I looking at and why is there an error and whose team is this? Then I haven't been able to keep context effectively. I want to be able to look at it, know which service, which error, what time, all these sorts of things. And that all sort of boils down to not missing an insight that could maybe make our lives easier, make our applications better. And oh my gosh, y'all, I think Lightstep does it all so good. And I just think Lightstep does a really good job of keeping that context. So I will link to this in a minute, but we have a sandbox you can play around in. And basically you can like sign in. Well, you don't have to really sign in. You click on play, but I'll send you the link. I basically was able to practice practice tracing an error with someone else's data, and like practice like, oh, find the root cause of this. It's really fun, especially because it's not your data and nothing's going wrong for you. And I think if it's easy for beginners and easy for folks who aren't really that familiar with observability or tracing, then that's a sign to me that it has kept this context. It can also do a lot more than that. It can also do a lot more than impress me. It can handle automatic deployment and regression detection, which again is like very good for your engineering teams. It can handle system and service diagrams so that it's easier to understand your deep system. Real-time and historical root cause analysis, which is, I don't want to say it's what everyone wants, because maybe you want something different, but it is certainly something that a lot of people are interested in. It can also do custom alerting so that you know and have some way to find out that things are going, wrong or are offline, whatever. And it's also easy to set up. Now, the reason I gave you all these examples with open telemetry ahead of Lightstep is that there's no vendor lock-in. Open telemetry is an open source project it's a CNCF project. And you can use any sort of tracing tool with Lightstep with open telemetry. And you can send things to Lightstep from open telemetry, but you don't have to. Just like you do not have to use open telemetry in order to use Lightstep, right? We want people to use what they have. So if you already have a tracing solution or metrics or logs or what have you, you don't have to change anything about what you're doing in order to use Lightstep. You can just start sending them to Lightstep. And I think that's pretty cool. Okay, this is like the fun customer part. So let me tell you a little bit about some use cases for Lightstep and these sort of like deep systems. This first one is from our friends at Twilio. And I think that like one of the reasons that we feature them is because they have so many services. If you're familiar at all with Twilio, they're just such a massive organization. And they wanted to be able to like identify traces of specific, interesting, noteworthy events, right? When they first came to us, basically what they said was that they could answer who, what, and where, but not why. So they know sort of like, okay, who did this, what happened, and where was it? But they didn't have any way to like follow up and ask, why did that happen? And that's kind of what Lightstep's super good at. So they were continuously analyzing transaction performance, like this data generated by over 40 services, which is like totally bananas to me. I love it. And they wanted a solution that sort of wouldn't create a lot of overhead for them, right? They already have their hands full managing all of their services. So we don't want to ask them to spend a ton of time or energy in putting in a solution. They just wanted like a macro view of their system and like a little micro view of their services. And they really just wanted to make sure basically their developers were building features and not spending time building a monitoring solution. And this is sort of my favorite number. After they implemented Lightstep as their observability solution, Twilio went from an average root cause analysis investigation time, right? So sort of like when they started investigating the root cause, it went from 40 minutes to under 3 minutes. That's bananas. It saved them almost like 20 hours a week. And that's sort of how we got to this number on the slide, which is a 92% reduction in MTTR. And I think that's like, it's awesome. It's impressive to me. I don't have 40 services in my code base, but if I did, I'd be impressed. And sort of the last one I'll touch on here a little bit is Under Armour, who definitely have a massive business, right? Like this is a brand you've probably seen, and they're not a tech company, right? They're I guess an apparel company, a sports brand. They wanted similar things. They wanted to make sure that their on-call engineers were better taken care of, so that they weren't, dreading being on call, and that they weren't afraid to ship code. They just basically wanted to say, like, there's just like, let's take the fear out of this process. And they understood that kind of dread and fear, it like translates into other organizational problems. And Lightstep solved that problem for them. It was able to like sort of remove that fear of on-call. And like related to that, because now they had context through Lightstep, through all of their telemetry, they were less afraid to make changes to their code because they could actually see what was being affected. It sort of changed the relationship between their engineers and their systems. And I think it's incredibly valuable, right, as an engineer, to feel confident that you know like what your code affects, what changes kind of ripple out from it. That's fantastic. So we sort of pride ourselves on Under Armour's 100% system visibility, which is really more about, like engineers' peace of mind and confidence. And I think that to sort of bring it back around, as Python developers, we often struggle with system visibility because of the many layers of dependency, because we want to write really cool stuff that works really well. Sometimes we need a solution like this to help us keep track. So now is when I tell you how to use the sandbox I was bragging about earlier. It's at lightstep.com/play. And it's just like a really fun way to understand what it would be like to use Lightstep for your application. There's a couple sort of like scenarios you can walk through, like, oh, well, here's like a little interactive practice run of how you would find the root cause analysis or find this particular error, those kinds of things. It's super fun. And whether I also do want to mention that pretty soon OpenTelemetry is going to have Python auto instrumentation. You can find it on the OpenTelemetry GitHub. They're working on it now, and basically that means it'll be even quicker to be able to add telemetry and like instrument your applications. So keep an eye out for that, because it'll make everything even easier. And that's all the prepared material I have today. I want to go to Q&A now because I like you all.
Very good. Thank you so much, Katy. And the audience, please submit your questions, and we'll answer as many as we can before the end of the hour. So, Katy, I want to start you off with a very interesting question, and it's, do you consider open telemetry to be a philosophy or a science?
That is an interesting question. So there is a lot of science behind OpenTelemetry. And yeah, I think I understand sort of where this question is coming from. OpenTelemetry is a standardization. So we often struggle with like, yes, we want to implement tracing, but we need to do that in a way that's like manageable for other engineers and other parts of our organization. So I think sort of the idea of observability, I would say, is like a philosophy, but once you've decided to use it, open telemetry is the science you use to make it happen.
Okay, very good. Thank you so much. Here's another question. Can it handle stock trading?
That's a good question. There's not a lot of context there, so I'll sort of do my best. Well, first, I'm going to say yes. And then I'm going to give you some sort of like better information there. So most of the time, stock trading is time series data. So yes, it can handle time series data. That's a lot of, it's usually metrics. So you could send those metrics in with really any tool to Lightstep. So whatever you're using for your metrics currently, whether that's maybe you have a time series database or you have some other like metrics solution, you can then still send those metrics to Lightstep, or you could use, I don't know if you would want to use open telemetry with your stock trading, because you might want to use something that's more specifically time series, but that would be up to you. But the answer generally is yes, you can use Lightstep to analyze stock trade data.
Okay, very good. How about, is it best to use one tool that gives you tracing, metrics, and logging, or should you select a tool for each?
Ooh, this is like this is the question of the day, I think I'm going to say, because this is what a lot of organizations struggle with. So this is what I usually tell people. If you already have tools, if you're already using certain tools, right? So let's say you're already using a logging tool, you're using Splunk or something. It's not usually worth ripping that tool out in order to start over. If you're starting fresh, I think it's better to use an all-in-one solution just for like simplicity, because as engineers, we spend a lot of time context switching, right? We say like, oh, well, now I need to jump from, the back-end code over to this monitoring section. And so one tool that can do it all certainly helps with the overhead on that. But like I said, if you already have something specific worked into your code, then I think work with it until you're in a position where you have the time and sort of engineering energy to replace it.
Okay, very nice. And audience, if you would like to enter a question, please do so now. We'd love to hear from you. And then, here we go. How is it different from Datadog or New Relic?
Yeah, it's a great question. So I put both of those solutions as, I consider them more traditional APMs. They certainly are very useful for like traditional monitoring, but I think like I'm a big fan of using tools that are built for a specific purpose. And I think that once you start trying to expand them to deal with these deep systems, that's not really what they were built for. So I particularly think that like traditional APMs are great for that architecture slide I showed with the, sort of monolith-esque architecture. But this sort of like Lightstep as a solution is definitely built for more modern, complex systems.
Okay, well, thank you so much, Katy. We're going to give the audience some more time back to their day. So we would like to thank you again, and thank you for your expertise that you shared with us. We'd also like to thank Lightstep, and we appreciate your sponsorship. And this was brought to you by adtmag.com. And we'd like to thank the audience, and we're good for the day, and we appreciate your attendance, and this concludes our webcast. Thank you.